Tonight we're looking into posts being spread on social media. They claim the James Webb Space Telescope spotted a large object about 10 light-years away moving toward Earth. Coincidences often defy the label of mere chance. Picture a game of pool. The balls are set in a tight triangle, and the player takes a shot. The cue ball strikes, scattering the others across the table. But then something incredible happens. One by one, against all odds, every ball funnels into the same corner pocket. What would you think in that moment? A rare fluke, unbelievable skill, or would you suspect something unseen, perhaps a tilted table? In our universe, some events are so improbable that they challenge reason. Imagine, for instance, a massive object hurtling into our solar system. Its gravity tugs on a planet, flinging it out of orbit into interstellar space. Now imagine it doesn't stop there but sends two planets flying off together, aligned so perfectly that they begin orbiting one another as they drift into the void. It sounds impossible. Yet improbability doesn't always mean impossibility. The James Webb Space Telescope, JWST, has recently uncovered something astonishing in the Orion Nebula. Amid the vast stretches of interstellar space where stars are born, it found two such rogue planets locked in a binary orbit. Each has a mass comparable to Jupiter, earning the nickname Jupiter mass binary objects or jumbos. But here's the twist: JWST didn't find just one pair, it found 40 jumbos, making up nearly 10% of all the free-floating planets detected in the nebula. This isn't just unlikely, it's puzzling enough to make scientists wonder if we're missing something fundamental about how the universe operates. It's as though the cosmic table legs might need a closer inspection. What's certain is that our model of star and planet formation needs revision. But how? That remains a mystery. Jumbos were first observed in October 2023 when JWST's advanced instruments captured high-resolution images of the Orion Nebula. Though they may exist elsewhere, they've been notoriously difficult to detect until now. Their relatively small size and the challenges of current detection methods, such as gravitational microlensing, have kept them hidden. Gravitational microlensing, which involves observing the brief brightening of a star as an object passes in front of it, is itself an improbable phenomenon. Albert Einstein predicted it but doubted it could ever be observed. Advances in technology have since proven otherwise, yet it remains a hit-or-miss method. It took the incredible sensitivity of JWST to identify jumbos with certainty. These newfound planets are young, just about 1 million years old compared to Earth's 4.5 billion years. But their behavior is what truly baffled astronomers. Unlike other rogue planets that wander aimlessly or orbit a nearby star, jumbos orbit each other, separated by about 200 astronomical units, AU, 200 times the distance between Earth and the Sun. This discovery is as perplexing as it is exciting. Jumbos challenge our understanding of planetary formation, dynamics, and the very nature of the cosmos. It seems the universe still holds plenty of surprises, and with each revelation, our perspective expands. Who knows what other marvels are waiting to be discovered? Binary systems are not unusual in our galaxy. In fact, they're quite common, particularly among stars. Roughly 1/3 of all stars in the Milky Way exist in binary or higher-order systems, where two or more stars orbit a common center of gravity. However, the likelihood of such configurations decreases as the size of the object gets smaller. For example, around 75% of massive stars are in binary systems. About 50% of stars similar in size to our Sun have a binary companion. For smaller stars, the probability drops to 25%. But when it comes to objects smaller than a brown dwarf, those that lack the mass to sustain hydrogen fusion and are only 15 to 75 times the size of Jupiter, binary configurations are virtually unheard of. In theory, they should be impossible. There's no known mechanism that would explain why such objects would pair up. Yet the James Webb Space Telescope, JWST, has overturned that assumption. When it surveyed the Orion Nebula, it discovered 540 planetary mass objects smaller than brown dwarfs. Astonishingly, 9% of these were binary pairs, and 2 even formed a triplet system. This defies existing models of planetary formation and rubs the laws of probability the wrong way. The frequency of these Jupiter mass binary objects, jumbos, is particularly perplexing. At 9%, the occurrence rate is far too high to be dismissed as a fluke. It has forced scientists to reconsider how planets and similar objects form. There are two primary theories for how jumbos might come into existence, but neither fits the data well. Planetary systems, especially in their early stages, are chaotic places. Picture a young Earth surrounded by molten rock, comets, and other space debris, colliding and coalescing over time. Dust gathers into rocks, rocks into asteroids, and eventually into fully fledged planets. But not all objects survive this process. Gravity can fling some material out of the system entirely, turning them into rogue planets. Even massive planets are vulnerable to ejection under the right conditions. Some scientists theorize that our solar system may have once had an additional gas giant, which was expelled by the gravitational influence of Jupiter or possibly Saturn. If true, it's a testament to the turbulent nature of planetary systems. This ejection mechanism could explain the abundance of rogue planets, which are thought to number in the billions or even trillions throughout the galaxy. But it doesn't explain the 9% of jumbos forming binaries. The odds of two rogue planets being ejected together at the same speed and trajectory and then capturing each other gravitationally are vanishingly small. The second theory posits that jumbos could form directly in interstellar space, much like stars. When a star forms, gravity pulls gas and dust together until the mass ignites nuclear fusion. In the chaotic environment of a nebula, where supernovae and solar winds scatter material, smaller objects might form before gravity pulls in enough material for a star. However, this theory runs into a significant problem: the opacity limit. As gas and dust collapse under gravity, the gravitational potential energy is converted into heat. For an object to continue growing, it must radiate this heat away. But as the object gets denser, it becomes more opaque, trapping heat and creating pressure that resists further collapse. This sets a lower size limit on what can form, generally no smaller than a brown dwarf. Anything less massive struggles to overcome this physical barrier. In other words, interstellar gas and dust tend to go big or go home. Without the gravitational pull of a nearby star or an exceptionally dense environment, smaller objects like jumbos shouldn't form at all. The discovery of binary jumbos challenges both of these formation theories. Neither planetary ejection nor direct formation fully explains their high frequency in the Orion Nebula. Moreover, the existence of triplet systems further complicates the picture. These findings suggest there are gaps in our understanding of planetary and stellar formation. The mechanisms governing these processes may be more complex and less well understood than previously thought. The Orion Nebula's jumbos are rewriting the rules of astrophysics, and scientists are racing to determine what this means for our broader understanding of the cosmos. Are these anomalies unique to the nebula, or could they exist elsewhere, hidden in the vastness of interstellar space? For now, the answers remain tantalizingly out of reach. This residual extra push allows hot gas to overcome its resistance to collapse. But once that barrier is crossed, the accumulated momentum is too great to stop it just forming a planet. Instead, you get a brown dwarf, something larger, or nothing at all. This is the crux of the opacity limit. It determines the lower mass threshold for objects forming in interstellar space. This leaves scientists searching for an additional factor that might explain how jumbos, Jupiter mass binary objects, could emerge in defiance of these limits. A breakthrough in understanding this process could offer a more elegant solution. If something could counteract the opacity limit, planets might form naturally from interstellar matter. If two such objects formed near each other, their mutual gravitational pull could easily lead to stable orbits, no star required. This explanation sidesteps the improbabilities of earlier theories, like ejected rogue planets miraculously pairing up. In fact, it raises the possibility that smaller planets, even Earth-sized or tinier, could form and follow the same pattern, remaining undetected, hidden beyond the reach of even JWST's capabilities. But perhaps the answer lies in revisiting an older idea. Back in 2001, long before jumbos were discovered, astrophysicist Alan P. Boss proposed a theory in the Astrophysical Journal. He suggested that magnetic fields could play a critical role in planet formation under certain conditions. According to his model, interstellar magnetic fields might expel a Jupiter-sized object from a collapsing cloud destined to form a brown dwarf or star. The smaller planet mass object would be left intact while the remaining cloud continued collapsing into a larger celestial body. At the time, this idea was speculative, with no observational evidence to back it up. But it's fascinating that Boss's theoretical sizes match the jumbos observed by JWST decades later. Perhaps jumbos aren't as surprising as we first thought. Maybe magnetism is the missing piece of the puzzle. It's still too early to determine if magnetism is the key to solving the mystery of jumbos, but it stands as one of the more intriguing possibilities. Understanding these enigmatic objects could help astronomers refine their models of star and planet formation and offer new insights into the physics of our galaxy. What we do know is this: the universe always finds new ways to surprise us. Just when we think we've seen it all, it reminds us of how little we truly understand. Keep looking up. The next revelation might just be around the corner.